Hello, my phenomenal viewers, and welcome on to this episode. On today's episode, we are going to be answering this GCE Advanced Level 2021 question 9. And the question reads, given the complex numbers z1 is equal to 4 minus 5i and z2 is equal to p plus 4i, where p belongs to the set of real numbers, find the value of p for which z1 times z2 bar is purely imaginary, where z2 bar is the complex conjugate of z2. Hence, find z1 mark and the arguments of z2 squared. Moment 2, given that z is equal to x plus iy, where x and y belong in the set of real numbers, find the locus of the point z such that z mark is equal to the mark of z minus 2 plus 2i mark. So, as you can see, the question is under complex numbers. Now, before we dive into providing a solution to this question, I would like to give a brief synopsis on what a complex number is. So when we talk of a complex number, it is simply a number that has two parts. It has a real part and an imaginary part. So any number that is written in the form a plus bi, where both a and b belong in the set of real numbers, and I here is called the imaginary unit, which is equal to the square root of negative 1. Then we see this number is a complex number. So any number that is written in this form, where a and b belong in the set of real numbers, and I there is the square root of negative 1, then we see that this number is a complex number. Since it has two parts, it has the real part, which is the part that is independent of the imaginary unit, and the imaginary part, which is the term dependent of the imaginary unit, which is equal to the square root of negative 1. So that is what the complex number is all about. Now, coming back to the question, we've been given two complex numbers, z1 and z2, and we are told that if z1 times z2 bar is purely imaginary, we need to determine the value of p. So let us dive into solving this question together, and I hope that you've already got your book and a pen so that you are going to join me as I provide a solution to this question. So, solution. So we have the complex number z1 to be given as 4 minus 5i, 4 minus 5i, and the complex number z2 to be given as p plus 4i. And we are told that z1, z bar 2 or z2 bar is purely imaginary. Now, when we say a complex number is purely imaginary, it simply means that the real part of this complex number is equal to 0. When a is equal to 0, then the complex number is a purely imaginary complex number. Then if it is a purely real complex number, then it shows that b is equal to 0, which makes this complex number to break down to a. So it will be what? Purely real. So, but the question says it is what? Purely imaginary, which is indirectly telling us that the real part of the complex number is equal to 0. But now we are told that this z2 bar is the complex conjugate of the complex number z2. Now, how do we obtain the complex conjugate of a complex number? For us to obtain the complex conjugate of a complex number, we simply change the sign of the imaginary parts of that complex number. So, if this is a complex number, then for us to obtain its complex conjugate, we are simply going to change the sign of the imaginary part. So this becomes a minus bi. So a minus bi is the imaginary conjugate of this complex number a plus b. So we are going to do the same thing here. So it shows that our z2 bar will now be equal to p minus 4i. So this is the imaginary conjugate or the complex conjugate of the complex number z2. So we now need to determine the product z1, z2. So we have z1 to be what? 4 minus 5i times p minus 4i. P minus 4i. So we are going to carry out our multiplication just the way we usually do our normal multiplication of two brackets. So 4 times p gives me 4p. 4 times negative 4i gives me negative 16i. Negative 5i times p gives me negative 5pi. Then negative 5i times negative 4i gives me plus 20i squared. So this breaks down to 4p minus, here I can see that negative I is common, so I can factor out negative I. From here I'll be left with what? 16 plus 5p other I. So this is the negative here. This is the negative I. Then since I is equal to the square root of negative 1, if I square both sides, it shows that I squared is equal to negative 1. So negative 1 times 20 gives me negative 20. So this implies Z1, Z2 bar is equal to 4p minus 20 minus 16 plus 5p, all this I. So this is the complex number Z1, Z2 bar. Now, since we are told that this complex number is purely imaginary, it shows that the real part of the complex number is equal to 0. So what value of p makes this real part to be 0? We just need to equate this real part, which is what? 4p minus 20 to be equal to 0. So this implies 4p is equal to 20. Therefore, p is equal to 20 divided by the coefficient of p, which is 4, which gives me what? 5. So it shows that p is equal to 5. When p is equal to 5, then the real part of this complex number is equal to 0, making z1 times z2 bar to be purely imaginary. So this is how you solve the first part of this question. Now it seems, hence find z1 mark or z1 bar and the arguments of z2 squared. So for us to determine the modulus of a complex number, z bar is equal to square root of x squared plus y squared. So from this formula, this is the formula that is used to determine the modulus of any complex number, where x here is simply the real part, then y here is the coefficient of the imaginary part. So this implies z1 bar will be equal to the square root of 4 squared plus negative 5 squared, and this gives me square root of 41. This is 16 plus 25, that gives me square root of 41. So this is the absolute value of z1, which we call it the modulus of z1. Now we need to determine the argument of z2 bar. So the argument of z2, the argument of z2 squared. Now we need to determine the argument of z2 squared. And for one of the properties of arguments, this breaks down to give us 2 times the argument of z2. So whenever you have a complex number raised to a certain power and you are asked to determine the arguments of that complex number, you simply take the arguments of the complex number, multiply it by the power that it has been raised to. So this is equal to 2. Now for you to obtain the arguments of any complex number, it is simply the tan inverse of y divided by x. The tan inverse of the imaginary part, that is the imaginary coefficient, divided by the real part. So this gives me 2 times the tan inverse of the imaginary part, which is what, 4, divided by the real part, which is 5. So this implies argument of z2 squared is equal to the tan inverse of this. The tan inverse of this times 2 is going to give me 77.32 degrees. 77.32 degrees. So this is the argument of z2 squared. So the moment of the question says, given that z is equal to x plus iy, where x and y belong in the set of real numbers, find the locus of the point z such that z mark is equal to the mark of z minus 2 plus 2i. So we have z to be equal to x plus I, y, and we have z mark to be equal to the mark of z minus 2 plus 2i. So what we are going to do here, since we know that z is equal to what? X plus iy, we are going to substitute this value of z into this equation given to us. So this implies I'm going to have x plus I y mark to be equal to the mark of x plus I y minus 2 plus 2i. So this gives me the mark of x plus I y to be equal to x minus 2, the mark of x minus 2. Then here I have plus y plus 2, all this I mark, close this. So like we saw earlier, this is a modulus of this complex number, and we saw that also obtain the modulus of a complex number, we simply take the square root of the real part square plus the imaginary coefficient square. So this implies I'm going to have the square root of x squared plus y squared to be equal to the square root, this is another complex number here, of x minus 2 squared plus y plus 2 squared. So if I square both sides, this is going to give me x squared plus y squared to be equal to x minus 2 all that squared plus y plus 2 all that squared. Now expanding the bracket gives me x squared plus y squared is equal to x squared minus 4x plus 4 plus y squared plus 4y plus 4. Now collecting like terms, I'm going to have x squared cancels with x squared, y squared cancels with y squared. I'm going to have 0 is equal to negative 4x plus 4y plus 4 plus 4, that gives me 8. Now bringing 4y this other way gives me 4y to be equal to 4x minus 8. That is, if I bring 4y this way and I divide by negative, I'm going to have 4y is equal to 4x minus 8. Now dividing all through by 4, this gives me y is equal to x minus 2. So it shows that the locus of this complex number z is the line y is equal to x minus 2. So any point that lies here satisfies this condition as been given to us. Any point that lies here satisfies this condition. So for instance, if you take the point 2, 0, because when x is equal to 2, y is equal to 0, according to this equation that we've obtained, and you substitute it in here, you are going to have the left hand side to be equal to the right hand side. So this is how you tackle this question. And if you loved this video, please help me and share so that it can be beneficial to other students as well. And if this is also your first time to come across any of my videos, please do not hesitate to either follow me or subscribe, so that whenever I upload a video like this one, you will be notified. And thank you for watching. Stay blessed.